Hello, and welcome to Nano Analytic Instruments. Today you will be seeing the AutoMET, the new member of the nanoMETronom-AFM family. AutoMET is a patent-pending invention that employs novel approaches for fully automatic operation of the AFM instrument in so-called step and image mode, making the AFM ultimately fast and easy. The tool is based on the well-established nanoMETronom-AFM platform, already used in many industrial and scientific applications. AutoMET simplifies sample analysis to a trivial optimization and adjustment of the AFM parameters. On the left, we can see the cantilever positioned above the wafer stage. It's attached to the XYZ scanner. On the right, we can see the top camera, side camera, top scanner, and wafer stage. The AutoMET tool is a fully automated system. The user can specify the needed number of measurements along their XY coordinates. The system is going step by step, doing imaging or simple profile measurements. This is called step and image mode. A top scanner is used to move the cantilever probe over the surface and functions with any wafer size. The sample stage, or the wafer stage, can be adapted for 3-inch, 4-inch, 6-inch, and 8-inch wafers. The accuracy of the sample stage is less than 100 nanometers. The cantilever scanner can have movement ranges from 30 by 30 by 10 microns up to 100 by 100 by 20 micron. Two cameras, side and top, are integrated for easy optical navigation. This is a view of the user interface. The left window shows the cantilever approach procedure from the side camera view. The top middle window shows the cantilever and the area of interest from the top camera view. It is used for position navigation. The bottom middle window shows the real-time development of the 3D AFM image during the scanning. In the top right window, we can see the real-time development of the 2D AFM image. The final window shows the live profile of the measured features and the auto approach step of the cantilever. Before we start the measurements, the user inputs desired measurement positions and selects the measurement mode, choosing from contact, non-contact, CD measurement, or others. Alignment marks on the wafer are used to match the coordinates of the stage and wafer. Now we begin measurements by positioning the cantilever to the previously chosen XY start position. The cantilever starts in so-called park position, about 12 mm over the surface of the wafer. As scanning begins, the cantilever descends to the surface of the wafer. Here we can see the cantilever beginning in park position. After the user inputs measurements, the cantilever moves to its first measurement position. The cantilever descends to the wafer surface and begins the first measurement. As the imaging sequence begins, a 3D map is presented in the bottom middle window, while the 2D topographical map is in the top right. Below the 2D map, you can see the profile of the features. Below the profile map, you can see the voltage from the piezo sensors. After the first measurement, the cantilever ascends to 500 microns over the surface and the wafer is moved to the next measurement point. This procedure can be repeated unlimited times. As the first image completes, the cantilever moves up to 500 microns and shifts over to the next position in the row. In the interest of time, some of the footage is sped up. After the cantilever finishes imaging in this row, it ascends and moves into the next row to begin a new sequence. After the final measurement, the cantilever ascends back to park position. In summary, a series of 15 AFM images, taken at previously selected points on the wafer, can be realized in less than 14 minutes. With the top-edge CD metrology method, we can get all 15 measurements in less than 2 minutes. For more information about the AutoMet or nanoanalytik, visit www.nanoanalytik.net. Thank you for your time and attention.